Okay, we are doing experiment number 3, which is the single replacement reaction with the zinc and hydrochloric acid. So first we're going to take the Erlenmeyer flask, the 150 milliliter container, and we're going to fill it with 15 milliliters of 6 molar hydrochloric acid. Okay, and now we're going to close it so nothing can escape nor enter the flask. And we're going to add a pressure gauge and a temperature monitor. So right now, as you can see, it's at 1 atmosphere, about 1.01, very close, and room temperature is 21.5 degrees Celsius. And then we'll add some zinc to the equation, 0.25 grams, to react with the hydrochloric acid. Right away you can see some bubbling happening in the flask, and you can see temperature rise as well as atmosphere. And right after the reaction, you can see it cooling down almost immediately as the bubbling is still occurring. Now it's stopped, and it's about 25.7 degrees Celsius when bubbling stopped. And as it's letting it cool down, we'll head over to the reaction.
As we can see on this screen, we see 2 moles of hydrochloric acid, which is aqueous solution, and also there's 1 mole of zinc solid, which is going to create 1 mole of hydrogen gas and 1 mole of zinc chloride. This is also called a single replacement reaction, where the zinc will take the place of a hydrogen gas, and hydrogen gas will increase the temperature within the flask. All reactions either produce or absorb heat, which is called enthalpy, and this reaction produces heat and is an excellent example of negative enthalpy. This heat expanded the hydrogen gas inside the flask, which caused the pressure to rise.
Now it's reading at about 22.5 degrees, which is very close to room temperature. So we'll go ahead and put the syringe in the flask right now. And as you can see right away, the syringe fills with gas, and it'll read about 93 milliliters. That's how expanded the gas became with the temperature. All right.